everyone, here is Mustafa. In this video I'm going to speak about Gibbs free energy and equilibrium. Let's get started. In topic 5 we have discussed Gibbs free energy, delta G, and we have said that it's an indication for the reaction spontaneity. So for a reaction to be spontaneous, delta G for the reaction must be negative. What does it mean by that? What does it mean by spontaneous reaction? If we have reactants are reacting without any external influence to make products, this reaction is called a spontaneous reaction. And we have delta G for this reaction. The value for delta G should be negative. So this means that the reaction is spontaneous reaction. If delta G is positive, so it is non-spontaneous reaction. Non-spontaneous reaction. Okay. Now we have to know that K gives an indication of delta G. How this is happening? We have said before that K is equal to the concentration of the product to the power of its coefficient over the concentration of reactant to the power of its coefficients. So if we have K higher than 1, it means that the concentration of the products is much higher than the concentration of the reactants, which means that the reaction is proceeding toward the products from the reactant to the products smoothly or without any external factor, or an indication for how easily the products are formed. For that reason here, we can say directly if K is much higher than 1, we can say that this delta G is negative when K is higher than 1, and this is a spontaneous reaction. But if we have K lower than 1, what does it mean by K lower than 1? So we have to check the reactants. The reactants concentration is much higher than the product's concentration. So here in this case, delta G is positive. Why delta G is positive? When K is lower than 1, it means that the reactants are hardly reacting to form products, so the reaction is non-spontaneous reaction. Non-spontaneous reaction. So we can see here when K is higher than 1, so the reaction is products favored. Reaction is products favored because the products are formed smoothly from the reactants. And here we can say that this type of reaction is a spontaneous reaction where delta G is negative. If a K is lower than 1, okay, so we have here R much higher than the concentration of R is much higher than the concentration of P, so the reactants are favored in this type of reaction than the products, and delta G is positive. It is non-spontaneous reaction. The mathematical relationship is found in the data booklet. Delta G is equal to negative RT ln K, where R is the gas constant, T is temperature, and of course K is the equilibrium constant. This relationship is showing how we can could be used to calculate the equilibrium constant using delta G, or could be used to calculate delta G using K. Okay, and of course, if we are asked about the spontaneity of the reaction, we can easily find it out. So we can manipulate this formula to find K by having ln K is equal to negative delta G naught over RT, then K is equal to e to the power negative delta G naught over RT. We have here a problem about the formula that we just discussed. Determine K for the following reaction at 300 Kelvin, given that delta H is negative 824.2 kJ per mole and delta S is equal to negative 270.5 joule per Kelvin mole, and we have here an equation. How can we find K if we have delta H and delta S? We can directly remember the first formula that we have discussed in Unit 5 about delta G. So delta G is equal to delta H minus T delta S. We already have delta H, we already have delta S, and T then we can directly find delta G. There is a very, very important point that we should not forget, which is the units. As we have mentioned before in topic 5, delta G is always calculated in kilojoule, while delta S is always calculated in joule. So you can observe here that I have divided the value of delta S over 1,000 to convert it into kilojoule to be able to find delta G. This is very, very important point. Then we have the formula that we just discussed from a while. Ln K is equal to negative delta G naught over RT. We have the value for delta G that we just calculated. We have 8.31, which is the gas constant. Then we have 300 Kelvin. One of you will tell me why you are multiplying by 1,000. Why? Because we have to unify the units. The unit for R is 8.31 joule. So we should convert this into kilojoule, or I can convert delta G into joule. So you can multiply the value for delta G by 1,000, or you can divide the value for R over 1,000, and you will get the same answer here. The answer is 298. So you don't have to forget about unifying the units, especially for delta S and delta G. And we don't have to forget that R is given in joule. We have delta S joule. We have delta G in kilojoule. Just consider that when you are calculating or using this formula. So K, if you manage to calculate it using your calculator, K will be equal to 2.6 multiplied by 10 to the power 129. Therefore, the reaction is highly favorable. Why the reaction is highly favorable? Because simply K is much higher than 1. K is much higher than 1. So the reaction is proceeding toward the products. So because K is much higher than 1, which means that the reaction is products favor. It's moving directly from the reactants toward the products, and the concentration of the products is much higher than the concentration of the reactants according to the expression for the equilibrium. If the concentration of the products is much higher than the concentration of the reactants, so K should be much higher than 1 as it is in our case here.